So in the previous video, we solved the question on variance of x on a circle. In this one, we'll extend this to the variance of x on a sphere. So the question says, suppose you randomly generate points on the surface of a unit sphere centered at the origin. What's the variance of x? So let's see how we can solve this. So first, we'll write the coordinates of a random point in terms of the angle. So let's say this is our coordinates. This is y-axis, this is x-axis, this is z-axis. Now, let's say this is the circle, and let me try to see if we can make it three-dimensional. Okay, so let's say this is our point, our random point, and the coordinates of this point are x, y, and z. This angle, which it makes with the z-axis, is phi, and this angle, which it makes with the x-axis, is theta. So if this angle is phi, which it makes with the z-axis, what will be the z-coordinate? So if we draw a perpendicular from this point onto this z-axis, like this, then the coordinate, this length would be the z-coordinate, and that would be the, if this is the radius, this would be r cos phi, would be the z-coordinate. Yeah, and this line, this distance, vertical, this would be r sine phi. Now, once we have this distance r sine phi, we can get the x-coordinate because we know the angle it makes with the x-axis, which is theta. So r sine phi times cos theta would give us the x-coordinate, and r sine phi times sine theta would give us the y-coordinate. So these are our coordinates in terms of the angle phi and theta. Now, phi is uniformly distributed such that cos phi is uniform between -1 and 1, and or equivalently, we have the PDF of phi equal to half of sine phi. So the way this works is this: we are changing the variables of the PDF. So let's say our random variable is y equals cos of phi. Yeah, and this is uniformly distributed between -1 and 1. So the PDF f of y is equal to 1/2 because it's a uniform distribution between -1 and 1. Now, what we want is f of phi. Yeah, so f of phi, we will write f of y. We'll first express y in terms of phi. So this becomes cos phi times dy by d phi. So this is the standard method of change of variable. You're given a random variable in terms of one variable, and you have to change it in terms of the other. You replace the variable and you multiply it by the derivative. So when we apply this, we get the PDF of phi, which equals to 1/2. Now, because we have to calculate the variance of x, we'll use the same formula as we used in the previous, which is the expected value of x squared minus expected value of x whole square. Because we have a sphere which is symmetric around the origin, the expected value of x is 0 by symmetry. The expected value of x square, now we know that x is sine phi cos theta from the previous slide. There's no r because the radius is 1 here, so x is sine phi cos theta, so x squared becomes sine squared phi cos squared theta. This becomes sine squared phi cos squared theta. Now, from the previous question which we solved on a circle instead of a sphere, we found that expected value of cos squared theta, where theta is the angle made with the x-axis, equals 1/2. So we put 1/2 for expected value of cos squared theta. And then what we need is expected value of sine squared phi, where we know that the PDF of phi is half of sine phi, as we saw in the next slide. So now we can use the formula for expected value of f. Expected value of x is x f of x times dx integrated from minus infinity to infinity. So we have to calculate the expected value of sine squared phi. The probability density function goes here. The function this will go here, and then we'll integrate it within the range which we have here. So we have expected value of sine squared phi. We put the function sine squared phi. We put the PDF here, and then we integrate it from 0 to pi to give us this expression, sine cubed phi d phi from 0 to 2 pi. Solving this gives us the expected value of sine squared phi equals 2 by 3. And we already know that expected value of x was 0. So the variance becomes expected value of x squared minus expected value of x whole squared. This part is 0. This was 2 by 3, and then we have expected value of x squared equals 1 by 3 because there's also 1/2 here. This gives us the variance of x equals 1 by 3. And this is the final answer to the problem. So for the case of circle, this variance was 1/2, and for the case of a sphere, it's 1 by 3. Thanks for watching, and I'll see you in the next video.